So we want to look at how slope applies maybe in the real world, and that's what I mean by applications here. So let me give you a reminder first. Slope is calculated or defined as rise over run, and of course that's a kind of vague without some context, but hopefully you already know what that means. But a more useful way to think of it as for applications or real world type problems where you have units and things is rise per run. Anytime you divide by a unit, it's per that unit. So this is the more useful version for applications. Okay? So that's the first thing I want to say. Now let's get into an example. Okay, so we have a graph here, and it illustrates Julie's electricity usage for 1 month. So on your y-axis, you've got her electricity usage in kilowatt hours, and on the x-axis, you've got which day of the month it is, okay? The question asks us to calculate the slope using these ordered pairs, and so you can see those ordered pairs on the graph somewhere. And then the important thing is we have to interpret the meaning of that slope in the context of this particular problem. Okay, so we need to locate the 2 points and calculate the slope. So 6, 36, 180. Well, that's got to be this point right here. So let me label that. And then the other one is 24, 36, 810. That's got to be this point right here. So now we need to calculate the slope using those 2 points. So I need to know my rise and I need to know my run. Okay, moving that direction maybe. So my rise, well, right now my rise, my y value is 36,180, and I'm going to go up until I hit this y value of 36,810. So going from 36,180 to 36,810 gives me a rise of 630 units. Okay? Then I do the same analysis on my run. Well, my run has an x value of 6 here, and it travels to the right until it hits an x value of 24. So my run is 18. Now let's be a little more specific here, because in this context, those numbers have units. So my rise is not just 630, it is a change of 630 kilowatt hours because it's a vertical change in this vertical axis. So 630 kilowatt hours. My run is 18 days. That's a change of 18 days. So now when I calculate my slope, I've got to consider my units. So my slope will be my rise over my run. So 630 kilowatt. I think I spelled kilowatt wrong up here. I think it only has one L. Kilowatt hours divided by 18 days. Okay? So now I just need to simplify this down so that it makes sense. And so what we end up with is we can divide the numbers to get a number, and we can divide the units to get, sorry, I keep spelling kilowatt with 2 L's, and we can divide the units to get our unit. So what we have is 630 divided by 18 is exactly 35. Yeah, that could be a decimal sometimes, and that's actually probably more common. But 35, and then when I divide these units, what you get is kilowatt hours divided by days is the same as saying per day. And so that language seems to make more sense when we think about it. 35 kilowatt hours per day. Okay, so that is our slope. That's the first question. What is the slope? 35 kilowatt hours per day. But now we need to interpret the meaning of that slope. Well, this is positive 35 kilowatt hours per day. So the meaning of that slope is that from the 6th day of the month to the 24th day of the month, Julie averaged, because it's an average because we're not actually looking at all the points in between. We're just taking 2 sample points here to calculate our slope. So it's an average. Julie averaged 35 kilowatt hours per day of electricity usage. She added that much electricity usage to her bill every day on average from the 6th day of the month to the 24th day of the month. Okay? So that's the meaning of that slope in this particular problem. It's a rate. It's a rate because it's kilowatt hours per day. That makes it a rate. How much per something. Okay? Now, one last thing about this. Another name for slope is average rate of change. You can see why. It's an average, as I said before, because you take just 2 sample points and you don't consider all the data in between. You just look at over that term from the 6th day to the 24th day, what was the average of the values from here to there? So it's an average. And it's a rate, as we said, because it's the vertical unit divided by the horizontal unit, the rise divided by the run. You get this unit of kilowatt hours per day from the dividing. So if we were to use the language of average rate of change for this problem, then we could say, so Julie's average rate of change from the 6th day to the 24th day was 35 kilowatt hours per day. All right, so that's how to interpret the meaning of a slope in an application problem. And you could also call that the average rate of change.